You probably already know the common FPS problem, that annoying hand clipping when you get too close to a wall like you saw in the thumbnail.
The classic method. The classic method involves using two cameras stacked on top of each other. One renders the first-person arms, and the other renders the environment. These two images are then combined, which gives you the final result. This is the most common approach and probably the first thing you'll hear when someone explains how FPS cameras are handled in games. Downsides. Well, it takes up quite a huge performance. Rendering a camera is already one of the most resource-demanding tasks in the game, so doubling that means your game will run even slower. The second downside to this approach is that the lighting in the scene does not influence the arm. On the bright side, this method is probably the easiest to implement, the most intuitive, and also supported by pretty much all the game engine. The tiny method. We have a 3D scene. In a 3D scene, there's a thing called perspective. What this means is that the closer you have your FPS arms to the camera, the bigger it gets rendered. Obvious, right? We can use this concept to solve the clipping problem. We shrink the arms and place it right in front of the camera. Because the arms are within the player's body collider, the arms will never be clipped with the environment. Pros: super easy to set up and it doesn't hit your performance. Cons: the lighting won't look as detailed, especially the shadows, because the arms are physically smaller in the game space. Also, if you want the arms to interact with the environment like pushing doors, this can be tricky since the arms are at a different scale. Another downside is that you can't separate the field of view for the arms and the environment, which could make the animations look a little off. Most games prefer to have a lower FOV for the arms and a higher FOV for the environment. If you want to add an FOV slider in the game, that's also going to be difficult. You'll only be able to adjust the entire FOV. Number 3. The collider method. This is pretty similar to the tiny arm method, but instead of shrinking the arms, we make the player's collider bigger, or we add a separate collider for the weapon so that the weapon cannot physically clip with the environment. Sounds good, right? Well, not quite. When you get next to a wall and try to do a smooth 360 turn, it won't work because your player collider now is not a circular shape. Number bonus. There's also an option using custom passes where the first person arms and weapon renders after everything else. From my experiments, it's unreliable and messes with screen space effects. Now, while the last 3 methods I've described fixes the problem with clipping, they don't address the next big issue in FPS games: separate FOVs for the arms and the environment. No matter which clipping solution you use, if you only have one camera, you can't avoid this problem. But here's an easy fix. Use first-person projection shader. This is actually provided by Unity's FPS sample. To use it, just create a new material, select this shader, and adjust the FOV. Boom. Problem solved. For my projects, I usually stick to the tiny arms method with a custom shader for separate FOVs. I make sure the arms fit within the collider without shrinking them too much. A completely different fix to solve the clipping issue is to animate the player's hand to lift the weapon when approaching a wall. To be honest, this also gives the extra detail to the game. This has been Semikoder. I kind of know how to code.